Thanks for clicking. Welcome to another Knowledge Math production. Today we're going to be talking about statistics and organized data. So we're going to be organizing data in different ways, like pie charts, line graphs, all sorts of stuff, and answer questions based on those graphs that you see. Okay? All right, so let's get started. All of you have worked with these before. So Mr. M's class grades were graphed as a pie graph. So here they are, A's, B's, C's, and D's. Based on that graph, the largest percentage of students received what grade? So which is the biggest piece of the pie? C, right? So C's are the biggest piece of the pie. So the largest group of kids got a C, all right? So that's how you interpret a pie graph. All right, so example. Now a bar graph compares the number of students enrolled in a class. Okay, here are my 5 classes: bio, chem, physics, earth science, and anatomy. And then up on the y-axis, it shows me the number of students. All right, which class has the highest enrollment? Well, which bar goes the highest? Bio. How many students are enrolled in chemistry? Here's my chemistry bar. It goes up to 140. How many are enrolled in anatomy? 100. Which course is the least popular? Physics. Seems to be always physics. Okay? All right, there's my bar graph and how I interpret it. Okay, let's try the same thing with a line graph. Same idea. All right, so it's a little hard to read. This is the X line here. This is the sun line here. Okay, so let's see if we can make this a little bit easier. So this, I'll trace over it in different colors to make it easier to read. So that's my X line. Ooh. Here's my triangle line. Then we have our sun line in orange. That was a good choice. And then finally, the 1 hour sunlight's on the bottom. We'll just leave that in black. Okay, so on day 7, the plants kept in the sun for 3 hours were how tall? All right, so here's the 3 hours of sunlight line. It's the orange line. On day 7, well, here's day 7. How tall were those plants? The height is 20 millimeters. There it is. On day 7, the plants kept in the sun for 6 hours. So 6 hours is my green plant, or green line. On day 7, the plants for 6 hours, that's the green line, were how tall? Looks like halfway between 60 and 80, so 70 millimeters. On day 10, the graph kept in the sun for 9 hours. Day 10, the graph kept in the sun for 9 hours is the red one. Okay, 9 hours is the red one. How tall? 140. On day 11, the plant with 1 hour, that's in black, was grown how tall? All right, so between 0 and 20, but definitely closer to 20 than the middle, right? It's not in the middle, so I don't want to say 10. I'm going to say 15. And then based on the graph, the plant grows best in what amount of sunlight? Well, which one has the biggest height? That would be the 9 hours. So 9 hours of sunlight is the plant that's going to grow the best, right? The more sunlight, the better off it'll be. Okay? All right, that's interpreting a line graph. Okay, now let's interpret this graph here. A class of students took a survey to determine which cake flavor is the most popular. If each student voted 1 time, how many students are in the class? Okay, each student voted 1 time. How many students are in the class? Now, there's a key down here. This key says each piece of cake represents 4 votes. Okay, so every cake isn't 1. Every cake is 4. So that's 4, that's 4, that's half a cake, so that's 2. So that means 4, 8, 12, 14 people voted for vanilla. 4 people voted for chocolate. 4 and 2, 6 people voted for strawberry. And 12 people voted for red velvet. So how many students are in the class in total? All right, 14 and 4, that's 18. 18 and 6, that's a 4, 2 to carry. No, that's a 4, 1 to carry. 2, 24. Wow, that was really difficult. 24, and then this is 12. So 24 and 12, 36. There are 36 students. It's multiple choice. That's my answer. All right. Okay, example 3. Here is a stem and leaf graph. What is the mode for the set of numbers? Mode is the number that appears the most. A stem and leaf graph means, for example, the stem is 3 and the leaf is 1, 4, 5, which means that the numbers in this row are 31, 34, and 35. Okay, the numbers in the last row are 65 and 68. So the stem means the number to start each one of these numbers is a 6. So that's 65, that's 68. All right, mode is the number that appears the most, right? Which number appears the most? Well, the 4 has 3 2s next to it. 5 has 2 1s. So it looks like the 2 with the 4. So 42 is the mode. Yeah, it's a choice. We'll circle it. Okay, 42 is the most. It's the mode. All right, the shape and spread of a sample set. Symmetry describes the shape of a set of data. A set of data is supposed to be symmetrical or is symmetrical when the values on the left and the right mirror each other. So this is the example of symmetric data. Okay, most of the data is in the middle, and then there's a little bit of data on the left and a little bit of data on the right. All right, there are 2 other types of data that you can have. You could have data that's skewed left. So skewed left, it's a little confusing, means most of the data is on the right. There's only a little bit of data on the left. Skewed right means most of the data is on the left, and there's a very little bit of data on the right. Okay, so there's 3 types of shape and spread: skewed left, symmetric, and skewed right. All right, so how is this data spread? This data is spread like that if we draw it. So most of the data is on the left, very little is on the right. So this data is skewed right. Okay, it's skewed to the right. All right, scatter plot correlations. We've worked with scatter plots many times. A positive correlation, okay, is if it looks like the data, when X increases, Y increases. So it looks like a line that has positive slope. Negative correlation looks like a line that has negative slope. When X goes up, Y goes down. X goes up, Y's come down. No correlation means that, well, it doesn't look linear and literally there's just stuff everywhere. Okay? Doesn't look like it's positive correlation or a negative correlation. All right? Those are our 3 types of correlations. Okay? Perfect correlation means all the points are in a straight line. So this would be a perfect positive correlation. All of the points are on the line, literally. Strong correlation, which both of these are, means the points are closer in relation to the line to one another. So they're really close to each other, okay, and they're really close to the line. Weak correlation means the points are located farther apart in relation to the line. All right. So, lines of best fit. A line of best fit is a straight line that represents the data on a scatter plot in the best way. The line could pass through all the points, some of the points, or none of the points. The line of best fit is also known as a trend line. If you're going to draw a trend line, you're going to use a straight edge to draw the line that has about the same number of points above and below. Okay, so if I draw my trend line here as best I can, I'm going to ignore this point. This point's like an outlier. It's pretty far away from all of the other points. So that looks pretty good. It's not too bad. All right, I got some points above it, some points below it. Okay, and the points for the most part are really close to the line with the exception of this one. This one is pretty far. I would call this one probably an outlier. All right, it's too far away from the rest of the points. Okay, two-way frequency tables displays frequencies from two different categories amongst the same set of people. So here's a two-way frequency table. Ooh. Some adults were interviewed to see if they would want to buy an SUV or a sports car. So here's what we have. What this table means is that 59 males were surveyed for this. 181 females were surveyed for this. 21 males liked the SUV. 38 males liked the sports car. Okay. A total of 240 people were surveyed for this survey. A total of 156 people like the SUV. All right. That's what we're talking about. Of the number of adults who preferred sports cars, what percentage of them were male? Okay. So really what this comes down to is answering this question is really about your fundamental reading ability. You have to read the question carefully and know which numbers they're talking about. Because there's 9 numbers in this chart. But we're not talking about all 9. We're only talking about a couple. All right. So the number of adults who preferred sports cars. So how many people like the sports car? 84. What percentage of them were male? So how many people who like the sports car? How many of them were males? 38 people who like the sports car were males. So the percentage is 38 out of 84. Okay, so now I'm going to put this in lowest terms first, and then I'll divide after that because I need to find a percent. So I got to go to 2 decimal places. So 2 definitely goes into both. 2 goes into 38. 1, 2, 18, 19 times. And 2 into 84. 2 into 8, 4 times. Bring down the 4. 2 into 4 twice. 19 over 42. So now to figure out the percent, I got to do 42 into 19. So 42 does not go into 19. Bring down the 0. Put a decimal. 42 into 190 is 4 times. So 42 times 4, 8. 16, 168. 8. Borrow. 22. Bring down the 0. 42 goes into 220. 5 times. So 42 times 5. 0, 1 to carry. 210. 10. Bring down the 0. I'm trying to see if I have to round. So 42 goes into 100 2 times. So I'm going to stop here. I get 0.452. So I have to move this decimal, 0.452. To figure out the percent, I got to move the decimal 2 spots to the right. I get 45. Oh, boy. 45. Try again. 45.2%. There's my answer. Okay? All right. Let's keep going. Dot plots. Each data point is graphed as a dot. So the dot plot below shows the high temperature in a city in degrees Fahrenheit over the last 2.5 weeks. For how many days was the temperature at most 49 degrees? So if it's at most 49 degrees, that's the most the temperature is going to be, right? If I tell you to go to the store and bring me back at most 5 apples, you can bring me 5 apples or less. You can't bring me 7. I said at most 5. Don't bring me more than 5. Okay? So we're talking about 49 or less. So where's 40? Here's 49. So 49, none of these are any good. How many dots are there at 49 or less? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 days. Okay, it was 49 or less. All right, outliers. To determine outliers, okay, what you're going to do is you are going to take quartile 1, subtract 1.5, and multiply by the interquartile range. We're going to talk about this in just a moment, okay? I think this slide's kind of out of place. We're going to talk about this in a minute, and we'll come back to it. All right? So what we're talking about is we're talking about a box and whisker plot. This is a box and whisker plot. All right? Box and whisker plot consists of literally a box and what we call 2 whiskers that extend out. These numbers are all important, and they can all be gotten from the data itself. All right. This number here in the middle, so to speak, is the median. All right. It's the value in the middle of the data organized from smallest to largest. The minimum value is the smallest value in the data set. The maximum value is the largest value in the data set. The range is the maximum minus the minimum. We did that before. Okay. The lower quartile, Q1, is the median of the lower half of the data. The upper quartile, Q3, is the median of the upper half of the data. And the interquartile range is Q3 minus Q1, which is what you would need to determine the outliers, the interquartile range. All right? Okay, so basically what we do when we want to make a box and whisker plot is the following, which is what we want to do here, is we're going to put all the numbers in order. It's actually a lot simpler than it looks. So 10, I'm going to cross them out as I go to make sure I don't miss any. 14, 14, 14, 15, 19. And we got 20, 21, 25, 25. Okay, so now here's what I want. I need to find 5 numbers. I need to find the minimum. I need to find the maximum. I need to find the median. I need to find Q1. That's the median of the lower. And I need to find Q3. That's the median of the upper. All right, so let me show you where all this stuff is. So some of them are easy. The minimum is 10. That's the lowest number. The maximum is 25. That's the highest number. Simple. The median is the middle number in the set of data, just like it always is. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 numbers. So the median is here, right? In the middle of, it's in the middle of these two. Right? 5 on this side, 5 on that side, right? Divided up. Yep. So the middle of 15 and 19, the number in between them is 17. Okay, I got to find the average of the 15 and the 19. So now, Q1 is the median of the lower half. So now you can see I just drew where the median would be, right? The lower half, this is the lower half. On the other side of the median is the upper half. So now what I want is the median of just these 5 numbers. Well, there's 5 numbers, so the median's the one in the middle, the third one. So the median of the lower, Q1, is 14. Q3 is the median of the upper set of data, just these 5 numbers on the other side of the median. So there's 5 numbers here. The median Q3 is 21. Okay, now I want to draw the actual box plot. So let's put 10 on here. We'll put 25. That's the max. And then we'll go by, we'll just go by 5s, I think, just to make it a little easier. So we got 15, we got 20, and 25. I'm not going to write all the numbers down. We'll just plot them where they belong. Okay, so let's plot them here. So we got 10. We're going to draw it above where the number line is. We got 25. And then we have 17. That's about right there. Okay, then we have 14, about right there. And 21 is about right there. Okay, so here's what we're going to do. We're going to make a box around the 3 medians. So here's my box. Comes in on the 3 medians. All right, we're going to draw a segment down through the box at the actual median. There it is. So this is Q1. This is Q3. This is the median. And then we're going to draw the whiskers to connect Q1 with the lower and Q3 with the upper. There's my box plot. Okay? So finding the numbers is actually not complicated. It's a little complicated to draw it. It's a little weird. But hopefully finding the numbers isn't complicated. You just basically are finding the median 3 times. Once for the whole set, and then once for the stuff to the left, and once for the stuff to the right of that median. Okay. And then finally, a box plot of prices of Bluetooth speakers is graphed below. What is the range in price of Bluetooth speakers? Well, the range would be the largest minus the smallest. So the largest is 120 minus the smallest is 16. So 120 minus 16. So I'll borrow that, make that a 10. 104. $104. Okay. If Bluetooth speakers under $31 are on sale, what percentage of the speakers are on sale? All right, so now, finally, in a box plot, every section represents 25% of the data. So that's 25%. All of these are 25%. From 16 to 31 is 25% of the data. 31 to 45 is another 25%. 45 to 71 is another 25%. Whoa. And then from 71 to 120 is the final 25%. So Bluetooth speakers under $31 are on sale. That's this area here. What percentage of the speakers are on sale? 25% of them. All the speakers prices that lie between $16 and $31 are on sale. That's 25% of the data. All right, and that's how box plots work. So a little bit different, but we'll be practicing them. And that's all. That's it. As always, thanks for clicking.